manage to hear. So in today's little app, we'll be making an app called Shake It, and it's just a little game, and it uses the gestures and the sensors that are built into the device to to give the user a motion that we want them to do, and then wait for that motion to happen and then give them points. So it's based on quite a silly game that I don't know if anybody has ever played, called Bop It, which is a sort of electronic handheld game, and it tells you to twist it or shake it or pass it around. So it's vaguely based on that as an idea, just as a way of seeing how to use the motions and sensors. So I think we'll just get started with the videos. Just load up the first one.
So welcome back to the beginners course at LiveCode Global, and in this session we'll be creating the Shake It app. Now when you're developing a mobile application, you'll probably want to take advantage of all the unique features of the device. So this could include using gestures, using the hardware that's provided as part of the device, and using the sensors. So we will be using the sensors and the motions to create a small game that gives the user an instruction about how to move the device and then detects when they take the correct action. So the game that we're going to make will have 3 random actions for the user to perform. So the first one is to tap the device in the right place, so just with your finger. Shake it, to shake the device, which is a gesture that you can respond to. And to hold it still. And for the hold it one, we'll be detecting how much they move the device as they try to hold it still, and if they move it too much, then they'll fail. So in the app that we're making, the user will have 2 seconds to perform each action, and the app keeps score. So it's going to be very simple. We're not going to speed it up over time or anything like that, just 2 seconds every time, and they have that amount of time to perform the action correctly. If they take the wrong action, then the game will end. So we'll start with a partially complete stack. It's a very simple stack. It only has 1 card, and on here we've got 5 controls. So we'll have a look at those. We've got a score field here. We've got an instruction field which tells the user what to do. We've got a start and stop button which can be used to start or stop the game. And here we've got 2 timer graphics. So one is the background of the timer and the other one is a slightly different color, and it shows the time passing. So these are both just oval graphics. You can see here that they're not opaque, but they do have quite a thick line on them. So those lines sit on top of each other, so as the time progresses, the different coloured one will grow until the time runs out. So it's a very simple stack, just 1 card, 5 controls. And what we'll do is we'll start with our stack script. Now most of our code is going to be on the card script, but in the stack script, so I'll open that up now, when we start up the stack, we're just going to set the full screen mode to exact fit, just like we've done with the other ones. So what we're going to do is we're going to add the pre-open stack handler, so on pre-open stack. And all we're going to do is set the full screen mode of me to exact fit. And this just means that whatever device you end up running this on, it will scale to use all the space on the screen. There are other options for full screen mode, but we'll just use exact fit. So that's all we need in our stack script. So what we're going to do next is we're going to get started with the card script. And the first thing we're going to do is we're going to sort of reset the card when it's first opened, ready to start a new game. So we're going to open up the card script. And you'll see here that now that I'm using version 8.16, and you'll see here we have a list of handlers that you might want to use. So this is just a way of saving a little bit of time, of seeing the handlers that are available, and of reducing any typos that you might make. What you can do is you can just select the handler that you want to create. So we want to create pre-open card. So if I click on that here in the list, it auto-populates the on pre-open card and the end pre-open card handlers for me. And what we want to do in on pre-open card is we just want to reset everything on the card. So the first thing we'll do is reset the score. So we'll put 0 into field score. The next thing we want to do is we want to set the label of this button. Now because this is our StartStop button, and we've just got 1 button, what we do is we change the label depending on what state the app is in. So of course when we first open the card we want to be able to start it. So we set the label of button start stop to start. So we know that that will show start on the button. And then the last thing we want to do is we want to reset our timer graphics. We want to set the arc angle of graphic timer. So we're just going to reset that so that our timer graphic effectively shows 0. Now if you've never worked with the arc angle before, what I'll do is I'll just show you a quick example. So if we create an oval graphic here, doesn't matter what shape it is, just as long as it's an oval. Now if I open up the property inspector here, you'll see that it's got a start angle property and an arc angle property. So at the moment the start is 0 and the arc angle is 360, which gives us a full circle. Now if I change the arc to something else, if I change it to 90, so 90 degrees, then we get a quarter of a circle, 120, we get slightly over a quarter of a circle, and the start angle tells us where the arc should begin. So 0 is here, so if we want to start somewhere else, if we want to start at 60 degrees, if we change the start, then you can see that our arc is still 120 degrees, but it actually starts at 60 degrees instead of 0, which is here, and it always goes in an anti-clockwise direction. So this is what we're going to use to create our timer. So you can see how if we start at 90, so it starts at the top, and if we start with an arc of 10, and then if we up that to 20, 30, 40, you can see how we can use this to create a round timer effect. Okay, so coming back to our stack, the next thing we want to do is we want to add some code to our StartStop button so that it will start the game if the text on it is start, and it will stop the game if the text on it is stop. So we'll select our button, open up the object script, and again we can choose our mouse up handler here if we want to. And what we're going to do in here is we're going to check the label and then do something different depending on what the label is. So we're going to say if the label of me is start, then what we're going to do is we're going to call the StopGame command, which we'll implement later. Otherwise, if it's stop, then we're going to call our StopGame command. And by using this method, we can just use the same button. So rather than having to have two buttons and show and hide them and have them in the same place, we can just change the label and then check the label to perform a different action. So what we're going to do now is we're going to come back to our card script and we're going to implement that StartGame command. Now the first thing we're going to do is we're going to create a script local variable, and we'll just use this to store the state of the game. So the game's either running or it's not. So we'll declare that at the top of our script here, and we'll call it SGameRunning. So if there is a game running, it'll be true. If there's not, it will be false. So the first thing we want to do when we want to start the game is we want to update that variable. So we're going to put true into SGameRunning. So the way that our game is going to work is we're going to have our three different instructions. So when we tell it to tap, we're going to tap on here. When we tell the user to shake, they're going to shake the device. And when we tell them to hold it still, we want them to hold it as still as they possibly can. Now, to detect whether they are holding it still or not, what we're going to use is we're going to use one of the mobile sensors. We're going to use the rotation sensor. And in order to use that rotation sensor, we have to tell it to start. So to start the rotation sensor running, because we don't want to be running the sensors all the time if we don't need them. So what we're going to do is we're going to check if we're on mobile. So we're going to say if the environment is mobile. So we do this because on a desktop we don't have these type of sensors. So telling them to start doesn't work on the desktop. So first thing we're going to do is we're going to check that we're on mobile. So we say if the environment is mobile. And if it is, what we want to do is we want to start the rotation sensor. So we say mobile start tracking sensor. And then we tell it which of the sensors we want to start, and we want to start the rotation rate sensor. And we tell it what type of information we want. So we're going to set that to false. Now if we have a quick look at the dictionary here, you'll see that the first parameter is the sensor that we want to use, in this case the rotation rate. And the second parameter is loosely, and that just tells the sensor how accurate we want the readings to be. So if loosely is true, then we want quite loose readings, so they're not so accurate, but we want our readings to be very accurate. So we say that loosely should be false. So that gives us nice accurate readings for the rotation sensor. So we've started the rotation sensor. Now the next thing we want to do is we want to update the label of our button here. So once the game has started, we want the user to be able to stop it. So we change the label, so we set the label of button StartStop. And we're going to set it to stop. And then the final step is to tell the app to choose an instruction and display it to the user. So we're going to call the display instruction command. And we'll just apply that. So the next command we're going to implement is the StopGame command. Now when we stop the game, we want to update our script local variable to say that the game is not running anymore. So the first thing we do is we put false into SGame running. Now we need this later when we're updating our timer. We're only going to want to update the timer when the game is running, which is why we keep track of this. Then of course what we want to do is we want to stop the timer. And then in here, once we've stopped the game, we also want to stop our tracking sensor. So I'm just going to copy and paste this. So again, we'll say if the environment is mobile, but this time what we're going to do is we're going to do mobile stop tracking sensor. And it's still the rotation rate, but we don't need that second parameter. So that just stops the sensor, so that won't use up so much power on your device. We're then to update the label of our button again, but this time we're going to change it to start, because we want to be able to restart the game, or to start a new game. Then we're going to update the score field. So this is just like when we set up the card when we first opened it. So we're going to put 0 into field score. And again, we're going to update our timer graphic, and we're going to set the arc angle back to 0. And finally, we're going to display an answer dialog to the user telling them that the game is over. So we're just going to say answer game over. Okay, so when we click on the button and it says stop, we'll stop the game from running, we'll stop the timer, we'll stop the tracking sensor. Then we'll set the label of our button, update the score, update the timer graphic, and display game over to the user. Now the next thing we need to do is we need to implement this display instruction command that we call from StartGame. So we'll do that now. So it's command display instruction. Now we want the game to choose a random instruction each time for us. So what we're going to do is we're going to give it a list of instructions and tell it to choose a random one. So we're going to put any item, so that's any of the items of, and then our list of instructions is tap, shake, and hold. So saying put any item of tap, shake, hold, we'll just choose a random item. And we're going to put that into a script local variable called sCurrentInstruction. Now the reason that we're going to store it in a script local variable is so that later we can detect whether the user has done the right action or not. So what I'm going to do is I'm going to come up here, I'm going to declare that script local variable up here as well, so that's sCurrentInstruction. And then what we're going to do is we're going to display the instruction in this field here, so we know if it's chosen tap, shake, or hold, but what we want to do is we want to put that current instruction, and then a new line, and then it, colon, so it'll say tap it, shake it, or hold it, and we want to put that into field instruction. So now we have chosen one of our instructions and we've updated the field to show the instruction. What we're going to do is we're going to start the timer, and we'll be looking at the timer in the next video. So now we've got our stack set up. We can update everything when we first open the card. We've got the ability to start and stop the game, to display the instruction to the user. So in the next video, we'll be looking at implementing the timer itself.
There we go. That was really interesting, Eleanor. That was,
Sorry, I wasn't quite ready for the video to end there. Okay, so that's the first part. So we've really just set up the card and got everything in place, and we're choosing our different actions. So So the way that the game will work is it'll just choose a random one each time and ask you to perform it. So in the next section, we'll be looking at how we actually generate the timer. So we'll have a little clock that ticks round. And I don't know if anybody has any questions at the moment. We haven't got any in the chat just now.
I actually have a question, Eleanor. I was watching that very carefully. So you check whether the platform was mobile.
Yes.
What do you do if it's not?
You don't do anything. So the reason that we do that is because if you try and start, so because the mobile start sensor, for example, that only works on mobile.
Mm-hmm.
If you try and execute that on the desktop, so in the IDE, if you click on a button to start something, then you'll get an error because it just doesn't exist. So that's why we always have to put the check in first to see if we're on mobile before we call any functions or commands that we know are only available on mobile.
Could you maybe, I don't know, pop up something that says, sorry, you need to play on a mobile device or something?
Yes, I mean, you could do that. You'd still want to do the check first,
yeah,
because you want to be able to control the problem. But you could do, if the environment is mobile, then do this. Otherwise, pop up something that says, sorry, this feature is only available on mobile. So you could do that. So you could give some feedback to the user rather than just doing...
But you're doing the check because otherwise you're going to get an error.
Yes, exactly.
Okay. Cool. Sorry, I'll carry on. I think you've got another question now.
We hear from Jonathan, which says, what if a mobile device has a broken accelerometer? Will bogus data freeze the app? So it depends. If it's broken in that it just doesn't work at all and doesn't return you anything, then it'll mean that it just won't be detected. So effectively, the device will believe that it's not moving at all, in which case you'll get the points even if you're shaking it about all over the place. The way that we're going to do it is we're going to put a sort of threshold on what we consider an acceptable amount of movement. But if your mobile device is giving you back sort of faulty data, there's not really any way for the app to know that what it's getting is faulty. It just will deal with the information that it's sent. There is a function that lets you check if the sensors are available. So maybe if you've got a very old phone, or this might work if something was broken or if something had been disabled deliberately, you can also check first to see if a particular sensor is available. So you can check that the accelerometer or the rotation rate or the heading sensor is available before you try and start it as well. So you could always put that extra little check in just to make sure that it's available. And like Heather said, if it's not available, so even if you're on a mobile device but you don't have a rotation rate sensor, then you could pop up a message saying your device does not support the rotation rate sensor, so it won't work. And then Terry said, I can shake my 27-inch iMac. I hope it doesn't respond to it, but I can, which is impressive because when I move my 27-inch Mac, I have to get somebody to do it for me. So the fact that you can shake it is impressive. I wouldn't recommend it though; they're very expensive. And then Sean said that you can send shake to the simulator, and you can, and we'll be using that later when we come to test it. We'll be able to test tapping. That's fine. We'll be able to test shake because you can do a keyboard combination, or you can choose it from the menu, and it will actually simulate shake on the simulator. The simulator doesn't simulate the sensors though, so you won't be able to check the rotation rate. But you can do a shake on the sensor, so you can always do a bit of testing there as well. Okay, that's great, John. Jonathan said that makes sense. This cheap Android device has a questionable mobile sensor. That just probably means it'll be harder or easier for you to play the game depending on if it gives you back bigger values or smaller ones. What if a laptop has a GPS sensor? So the functions that we're using are mobile only. So the mobile start sensor, that is just for mobile devices. So that's for iOS and Android. So even if you have a GPS sensor, that particular function, it won't do anything because it's just it's just available for iOS and Android. There may be other ways that you could hook into a sensor on your laptop, maybe using a library or I don't know, part of Infinite LiveCode, depending on what the APIs are like. But the commands that we're using are mobile, iOS and Android only. So even if it is there, it wouldn't work in this particular case, but it might work in other cases. Okay, well, if you have any more questions, you can pop them in the chat and we'll look at them in the part between the next two videos. But if we don't have anything at the moment, I'll just start the next video.
So now that we've got everything set up, we're going to start working on our timer. So the first thing we're going to do is we're going to implement the start timer command. Now all the timer commands will be using some script local variables to share information. So I'm going to declare those all now. So we'll have StartTime, so that's the time that the timer was started. SCounter, which is how many sort of ticks it's gone through. And STimerRunning, which, just like game running, will either be true or false to say whether the timer is actually running or not. So those are the three script local variables that we need. So when we start the timer, the first thing we're going to do is put the milliseconds into SStartTime to record the time that the timer actually started at. Now the reason that we're using the milliseconds is because we want to update our timer in fractions of a second. So we record the milliseconds. We're then going to put 0 into counter because no ticks of the clock have happened yet. We're then going to set the start angle of our graphic timer to 90. If you remember in the first video, I showed you that the 0 is for the start angle is actually here. So if you want it to start at the top, you have to set it to 90 because it goes round in an anti-clockwise direction. So we set the start angle of graphic timer to 90. And to make it look like no time has passed, then we'll set the arc angle to 0 as well. So I'm actually just going to copy this. But this time we want to set the arc angle and we want to set it to 0. So now what we'll get is an arc that starts up here but actually hasn't got any arc yet, so it will effectively be invisible until we update it. Then we want to put true into timer running to say that the timer is running. And then finally what we want to do is we want to tell the timer to update itself in 100 milliseconds. So we're going to update it 10 times a second. So we will send that message in 100 milliseconds. We want 100 milliseconds to pass and then we want the timer to update. So we send update timer to me in 100 milliseconds. Okay, so when we start the timer, it'll record the start time, put 0 into counter, say that no ticks have happened yet. We'll reset the timer angle, so we'll set it back to the starting point. We'll say that the timer is running and we'll tell it to update itself in 100 milliseconds. So next what we need to do is we need to implement this update timer command. So when the update timer command is received, so when after it's been sent, then we know that 1 tick has passed, so we add 1 to SCounter. So we always know how many sort of ticks round the clock we've done. We're then going to update the arc angle of our timer graphic to show the time that has passed. And because we'll be updating it 20 times in our 2 seconds, and there's 360 degrees in a full circle, we're going to be updating it by 18 degrees every time the counter goes up by 1. So we'll set the arc angle of graphic timer to whatever is in SCounter times 18. So when 1 tick has happened, we'll have an 18-degree arc, then 36, and so on. So we set that to show the timer. Now next what we're going to do is we're going to check if the timer is still running. So we say if STimerRunning is true. Now we do this because we only want to update the timer if we believe it's still running. So if the user hasn't stopped it or the game hasn't ended because the user's made a mistake. So we first check to see if the timer is still running. And if it is, then we want to check and see if our 2 seconds of allowed time have passed yet. So what we do is we say if the milliseconds, so that's the current time. So we say if the current time is less than the start time that we recorded plus 2000, so that's basically saying if it's within 2 seconds of the start time. So if we are within our 2 seconds, then what we want to do is we want to tell the timer to update itself in another 100 milliseconds. So if the timer is running and less than 2 seconds have passed, then we tell it to update again in 100 milliseconds. Otherwise, so basically if the timer has stopped or the time has run out, then what we want to do in this particular case is there's two possibilities. So one is that the user has been told to hold the phone still for those 2 seconds, and the other is that the 2 seconds have run out without them doing the correct action. So first we'll check to see if they're supposed to be holding the phone still, because if they're supposed to be holding it and they've reached 2 seconds and it hasn't been ended by too much rotation, then actually they get a point. So we check the current instructions. Remember, we recorded the current instruction earlier. So we see if the current instruction is hold, then actually what they've done is they have reached the end of the 2 seconds while they're supposed to be holding it. So what we do is we tell it to check action hold. Otherwise, we assume that the time has run out. So in that case, we stop the game. So we call StopGame, and that's it. So what we do when we get update timer is we add 1 to sCounter and we update the angle. Then we check to see if the timer is still running. If so, we check to see if the time has run out, if our 2 seconds have run out. If not, we tell it to update itself again in 100 milliseconds. If the timer has run out, then we check to see if the user was supposed to be holding it. If they were, then we call the check action command, which will decide if they get some points or not. And otherwise, we stop the game because we know that the 2 seconds have run out and the user hasn't performed the correct action. Now, of course, the last thing we need to be able to do is we need to be able to tell the timer to stop. So if you remember when we implemented StopGame, one of the things that it does is it calls stop timer. So we'll implement stop timer now. So it's stop timer. Now the first thing that this does is it updates the S timer running. So it puts false into S timer running. And this means that when we get here in our update timer, if it's false, then we don't do any of this. So if it's false, then we don't send update again, we don't check the action, we don't do anything if the timer is no longer running. And then the other thing that we want to do is we want to cancel any pending messages. So because we're using send in 100 milliseconds, then by the time we get round to executing this, there could be some messages queued up that are waiting to be sent in those 100 milliseconds, and we just want to make sure that none of those happen because we've already stopped the timer. So what we do is we check the pending messages and then we cancel each of the messages in the pending messages just to ensure that we don't get an update timer after we've stopped the timer. So what that does is that just cancels any messages that are waiting to be set. Okay, so what we can do is we can now test this out just using the message box. I'm just going to call start timer. And you should see that ticking round until it gets to the end, and then the timer runs out of time, stop game is called, and we get our game over message. I'll just show you that one more time. So you can see it ticking around and then it ends. So that's how we create a timer.
Okay, so I hope that was useful. Actually watching the video now, I can see that maybe it's not that clear that the timer's moving around because there's a light red background and a dark red timer, which is not quite as clear on the video as it is initially, but hopefully everybody could see what was happening there and that everything we were doing made sense. We don't have any questions in the chat at the moment, but if anybody has one, you can pop it in there and we can have a look at it just now. Otherwise, we can move on to the next video, and you can always drop your questions in the chat anytime, and we'll have a look at them in between. I'll just have a little, give it a few seconds in case anybody's got a question to ask just now. Okay, so if we don't have anything at the moment, we'll move on to the next video, which is where we actually detect the actions that the user is taking. So we wait for the tap or the shake, or we detect how still they're managing to hold the phone. So that's the bit that will actually give people a score and sort of set the game running. So I'll just start that video now.
Okay, so now we've got our timer running. What we want to do is we want to be able to actually detect the actions of the user. So the first one we'll look at is the tap action. Now we want that to work by when this says tap it, we want the user to tap within this circle. So what we're going to do is we're just going to say as long as they tap on this instructions field, then that counts as correct. And we'll do that by checking the mouse up message. Now by adding it to the card script here, we'll get it wherever the user taps or clicks on the card. So the first thing we want to do is check that they did in fact tap within this area. So we say if the short name of the target, that will give us the short name of the control that was actually clicked on. So we want that to be instruction, because we want to check that they tapped within the instruction field. Then what we'll do is we'll check the tap action. So we say check action tap. So all we're doing is we're waiting for a mouse up message, and then we're going to check that they were supposed to be tapping. Now the second one is the shake motion, and again what we're going to do is we're going to wait for a message that tells us that the phone has been shaken. So we can do this using the motion start message. So we can say on motion start, so this is sent to your app by the device if a motion happens, and it tells you which motion it detected. So just like we checked the short name of the target here, we're going to say if P motion is shake, because that's the only one we're interested in. So if P motion is shake, then what we want to do is we want to check that action, and this action is shake. So now we can detect taps and we can detect shake motions. Now the final one is when the user has to hold the device still. And for that one, what we're going to do is we're going to check for the rotation rate changed message. Now because we started the rotation rate sensor, we'll get a message from the device every time the rotation rate changes. So the rotation rate changes when the phone moves. So again, we'll handle the rotation rate changed message. And what this gets is this gets three parameters, the X, the Y, and the Z rotations. We'll call it RX, RY, and RZ. And to detect if we think that it has moved too much, what we're going to do is we're going to check the value of each of these against a constant that we think is an okay level. And if it's less than that, then that's fine. We consider that they haven't moved too much. And if it's more, then we think they have changed too much. Now these values can be positive or negative, so we want to check their absolute value. So we're going to say if abs Rx is greater than our rotation level. And what I'm going to do is I'm going to declare a constant at the top. So I'm going to declare a constant up here beside our script local variables. So we're going to say constant K rotation level. And because it's a constant, you can just give it a value directly up here. And I've decided to set it to 0.5. So if they move it more than 0.5, we're going to say that that is too much. So if I come back down here, so if the absolute value of Rx is greater than K rotation level, or the same for Ry and Rz. So basically what we're saying is if the value of any of these rotations in any direction is above this level that we consider to be okay, then what we want to do is we want to check that the instruction actually is hold. So we say if current instruction is hold, because really we want them to be able to move the phone as much as they want. If they're supposed to be tapping or shaking, that's absolutely fine. So we check that the current instructions, the instruction they're meant to be following, is hold. And we're also going to check that at least half a second has passed. And that's just because in terms of starting to hold the phone still, if you've just done a shake or you've just done a tap, then we want to give them a little bit of leeway to start holding the phone still, because otherwise if it starts immediately they're just going to fail. So we're going to check that the current time, so the milliseconds, we say and the milliseconds is greater than S start time plus 500. So we're basically saying if at least half a second has passed since the timer started, then, so if they're supposed to be holding it and enough time has passed, and it's more than the allowed level, then we're going to stop the game. Okay, so now we can detect taps using mouse up, we can detect shake motions using motion start, and we can detect how much the phone has sort of shaken or rotated using rotation rate changed. Now both mouse up and motion start, and if you remember also update timer, all call this check action command. Now this allows us to check the action that we detected against the current action, the one that the user is supposed to be performing, and then to decide whether to update their score or whether to end the game. Now rotation rate is a little bit different because we're handling that all in here, and we're stopping the game if it shakes too much. But if we think they've been successful, then the check action for hold actually happens in update timer because we're waiting for the time to run out. So the last thing we need to do is we need to implement our check action command. And we get a parameter telling us which action we're checking, whether it's hold, tap, or shake. And so the first thing we do is we check if the action that we're passed is the current action. So we say if P action is S current action. And so if the action that we're passed is not the current action, then the user has done the wrong action. So in that case, we want to stop the game. So if they've tapped when they should have shaken, or shaken when they should have tapped, we want to stop the game. But if the action that we're checking is the current action, then what we want to do is we want to firstly provide some feedback to the user to let them know that they've got it right. So we'll say if the environment is mobile, then. And what we'll do here is we'll tell the mobile to vibrate. So we'll do mobile vibrate. And that just causes the device to vibrate. So that's just sort of going, if you tap and you're supposed to tap, it does a little vibrate to let you know that you've got it right. And then what we want to do is we want to stop the timer. We want to add 1 to field score. So we're upping their score by 1. And then we're going to generate a new instruction for them to follow. So we call display instruction. And that's it. So when we check the action, all we're doing is checking the action that we've detected against the action they're supposed to be doing. If they don't match, then we stop the game. If they do, we vibrate the device. We stop the timer because they've done the action. We add 1 to their field score, and then we generate a new instruction for them to test. So that's it, that's our game. So what we can do now is we can quickly test it on the simulator. So what we'll do now is we'll set it up for iOS testing. So what we'll do now is we'll set it up for testing. So we'll open up the standalone application settings, we'll go to iOS. I've already got the internal app ID in here, and we've got the icons as well, and we've got a splash screen. Now you can grab all these from the resources for this lesson. Okay, and what I'm going to do is I'm going to put it on the simulator first. Now in the simulator we can check tap and we can check shake because we can simulate those actions. What we can't check is the rotation rate, so we'll need to put it onto a device to test that. But we'll test with the simulator first. Okay, so here we have it running on the simulator, so we can start it here. So we can tap, 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 shake, tap, hold it. So you'll see our score is going up. We're getting to the end of our 2 seconds, and if the time runs out and we haven't done it, or indeed if we do the wrong action, which I'll do now, so if I tap but I shake, then the game is over. Okay, so next what we'll do is we'll put it onto a device and we'll actually see it running there.
So now I've just got a really short video of it actually running on a phone, so I'm just going to turn that on and then we can come back to any questions or discussion that we want to have. Okay, so it looks like that video is actually not available. It's not very exciting. It's just the app running on my phone. I don't know how
it did show here. I could see it. Yeah.
Oh, I couldn't see the video, but it is, yeah. So you can just see that it's running on the device, and the shake and the holding it still does work. So let me just check if we've got any questions. So Jonathan's asked, are the values returned by different mobile devices reasonably consistent for rotation rate change for similar movements? I don't actually know for sure. I would imagine that they probably are. I know we've got at least one customer who uses the rotation rate and actually the accelerometer as well as part of their device, as part of their app, sorry, and it's quite an important part of their app, and they don't seem to have any problems with inconsistency, but they are iOS only at the moment. I imagine that you probably just have to do a bit of testing, but it's probably fairly consistent. I assume that the rotation rate changed will be the sort of something that I think it's always under 1. So I think it's mathematically it'll be sort of the rate of change as you actually move the phone. But I couldn't say how consistent the results would be. I guess that would be something you'd have to test if you wanted to use it as part of your app. And then Tom has asked, how would you decrease the timer period to increase difficulty? Right now, timer is hard-coded for 2 seconds. So what you could do is you would do something like you would maybe use the score field, and once the score goes above a certain amount, you would be able to change the time. So once your score gets to 20, say. So although we're hard-coded, the part of the code that checks if the current time is start time plus 2000, instead of using 2000 in there, you could use a variable, or you could use a little function call. So you could say something like, if the milliseconds is greater than start time plus allowed time function, and in the allowed time function, you would say if the score is less than 20, return 2000. If the score is greater than 20 but less than 30, return 1500. So you would maybe just use a little function in there that would use the score field to decide how long in there. So rather than just having that 2000 hard coded in, we'd put in a little function that would return the amount of time that we wanted to allow. It wouldn't be a difficult thing to do, and the score field would be quite a simple way of deciding when to change that, because we're already recording that. Yes, we've got a little bit of time left. This was a slightly shorter app to make than some of the others. So if you have got any questions, do pop them in here. And I would say Heather can maybe jump in here, but I know that if you're interested in using the sensors in a device, in your app, then one of the lessons that we've got in the ABC course, which recreates the Compass app, is a really nice one for that, because it uses the heading to do the compass points, and then it also does a balanced one. If you have an iPhone and you've ever used the compass, you'll know that there's a second screen there, which is actually, what are they called? A spirit level, effectively. So if you are interested in that, that's a really nice, like, more in-depth look at how you can use the sensors to do different things. So to do the compass and to do the little spirit levels. If you're putting up shelves, you can just use your iPhone to check if they're straight or not. So I don't know if anybody has any other questions, or got 10 minutes left. So if you do have any questions at all, actually, it doesn't have to be about this.
Usual, yes. It's quite rare that this must be one of maybe 2 or 3 sessions that have actually finished within the allotted time. So very good. So yeah, you get all the bits of that app in the materials when I send them round. I guess we could use this moment just to remind you that we do have the Slack channel, which if you want to join, look, I can put up your joining link here, so you should see that in your chat now. So if you didn't already join the Slack, you can join that now, which is nice if you want to go and chat afterwards, or you think of something that you wanted to ask, or later on if somebody hasn't finished their session, they can maybe pop over there and answer your questions there. So it's always worth joining that Slack channel. Yeah. Well, guys, unless anyone has any other questions, we might just finish this a couple of minutes early so you can all go grab a cup of tea or coffee or beer or whatever you fancy before the next one, which will be Ali, I believe. Just a heads up there that no, it's not Ali, it's Brian Anderson is next. Brian Anderson is next with a very interesting presentation. And then we have Ali with building widgets at 3:30.
And I will see you all back here next month for Picket, where we will learn how to use all the different types of mobile pickers.
Oh, so, exciting.
Yes, Picket.
Okay. All right then.
Thanks, Heather.
Okay. Thank you, everybody. And come back in a few minutes for Brian Anderson.